Hey guys, welcome to my channel EC Arbit. Today we are going to see about PYQ. If you are new to this channel, kindly watch the previous part 1 digital electronics video which I have mentioned in the playlist. The first question is, a bulb in a staircase has two switches, one switch being on the ground floor and the other one on the first floor. The bulb can be turned on and also can be turned off by any one of the switches, irrespective of the state of the other switch. The logic of the switching of the bulb resembles. See here, the logic used behind this is, if one switch is in the ground floor and the another switch is in the first floor, if we turn on one switch in the first floor and turn off another switch in the ground floor, means the logic used behind here is XOR gate. See, you all know the truth table of the XOR gate. For 0-0 combinations, it will be 0. For 1-0 combination and 0-1 combination only, it will get 1. So for 1-0 combination and 0-1 combination, the bulb gets turned on. Important. Second question is, find the logical expression. See here, two gates are given and two inputs were given to this gate. We need to find the final output. One gate is OR gate and the another gate is NAND gate. See here, for Y, the inputs are N and M. For Z, the OR gate input also, the OR gate output will be given input to the NAND gate and the N is given input to the NAND gate. So the final expression is Z is equal to N bar. See this. Third question is, identify the logic gate. See, the logic gate given here is NOR gate. Fourth question is, which logic gate is equivalent to the combination of logic gates? See this diagram. A is given as input to one NOT gate and B is given as input to another NOT gate. The output of NOT gate means whatever the input we will be giving, the complement will be the output. So A means A bar and B means B bar. Then NOR gate is the output. For NOR gate, we will be getting Y is equal to A bar plus B bar, the whole bar. Using De Morgan's law, A double bar dot B double bar, AB. The final is AND gate. Next fifth question is, identify the logic gate. The logic gate here given is an AND gate. And then convert the hexadecimal number C6 to the binary number, which was asked in Railway Recruitment Board Junior Engineer. See here, C6. For C, we all know in hexadecimal, 0 to 9 we have to write directly. For 10 we will be using A, and for 11 B, 12 C, 13 D, 14 E, 15 F. See here, 1100 means 12. So we have to write C. And then 01106. To find hexadecimal, we have to combine all the binary digits in 4 bit. For hexa, we will be combining all the bits in 4. For octal, we will be combining all the numbers in 3. Which of the following is not a binary number? Binary number means 0 and 1. Other than 0 and 1, it is not a binary number. So see here, E. Option is D. What is the hexadecimal equivalent of this binary number? 1110 base 2. So we all know 1110 means hexadecimal number is E. That is 14. See this. Next, the question number 9 is the octal representation of A0E base 16 is A means 10. 10 means 1 0 1 0 0 0 0 0 0. E is 14. 111 0. For octal, we have to combine all the bits in three digit, like 110 we have to combine, and then 100 0 000 101. 110 means 6. 1 and then 001 means 1. 0000 1015. So the final answer is 501816, the base 8. And then the question number 10 is the range of values that can be represented with 8-bit in 2's complement form. To find the range of 2's complement form, the formula we have to use is minus 2 power n minus 1 2 plus 2 power n minus 1 minus 1. If we substitute n is equal to 8 in this formula, means we will be getting minus 128 2 plus 127. The option here is D. Question number 11 is, what is the number of bits in a byte? The number of bits in a byte is 8. Nibble means 4 bits. 4 bits form a nibble. 8 bits form a byte. And then binary explanation of 129.25 is, see here, 129 means we have to do in this way, like LCM format, 129 to 64, the balance will be 1. Like this we have to do up to last. From bottom to upwards we have to write 1 000 and then 000 1. For for 25, for decimal 25, 0.25 into 2 means 0.5. 0.5 into 2, 1.0. Up to 1 we have to do this process. If 1 comes means we have to stop this process. In this decimal we have to write in upward to downward. Then the answer will be 1 000 000 1.01. Then next question is 2's complement of binary number 1 000 11 000. We need to know what is 1's complement and 2's complement. 1's complement means just inverting the number. We have to invert all the bits. 1001 means we have to invert all the bits, like 1 means 0, 0, 1, 0, 1 and then 1, 0. This is the 1's complement. For 2's complement, we have to add 1 to 1's complement. For example, 1100. 1's complement is inverting all the bits 0, 0, 1, 1. 2's complement means we have to add 1 to the 1's complement. We will be getting 2's complement, like 110 and then 110, 1, 0, 0, 1, 00. Like this way, 13th, we have to find 13th question. Solution is 1 000 1100 is the question. For 1's complement, we need to invert all the bits. 1 0, for 000 111, 1100, 0011. To get 2's complement, we will be adding 1. The final answer is 0 111 0100. And then 14th question is decimal 14 is equivalent to binary number. We all know 14 is 1110. 15th question is the 2's complement of the binary number 1100 1100. Find the solution and comment in the comment section. If any query, do it in comment section. I will answer your all queries. Thanks for watching. Stay tuned for more videos. Kindly do share, subscribe and like.